Welcome to Edulution 2.0. Edulution was originally created as an answer to the COVID-19 pandemic, when the world went remote and students lost their opportunity to be in the classroom. To help prevent students from falling behind, Edulution filled the gap for those who didn't have Wi-Fi or technology. Edulution has supported the community for over 2 years, filling the educational divide through equity and access, ensuring that all students have a fair chance to learn and succeed in life. Our host is Ms. Pia Rosa, a Bronx-born and raised educator with a heart for her community. Let's start the show.
Welcome to another episode. Where are you right now? Well, wherever you are, just know we are here to bring you love and learning to you.
Hello, it's Mr. John here. Let's solve a puzzle. Today, we are going to do a math workout to build our math muscles. You will need a piece of paper and something to write with. The puzzles we are going to work on are called area mazes. Using the visual clues and the number clues, we will be able to solve the puzzle and say, I got it. Okay, before we see the first puzzle, I want to check in with you. Let's look at this shape that I've drawn on my board. It is a rectangle. If the puzzle tells me that this side is 6 units, I also know that the opposite side is 6 units because that is what it means to be a rectangle. Opposite sides are the same length. We also know that a rectangle has a total of 4 sides and 4 right angles. And sometimes you will see the symbol like that to show that those are right angles. But you won't see those always on these puzzles. Keep in mind that when you do an area maze puzzle, they are not drawn to scale. What does that mean? Well, it means that you should not rely on how it looks. Instead, rely on the information that they give you and what you know about the shape. Here's what I mean. If I tell you that this side of the rectangle measures 5 units, you can rely on that as good information. Of course, you may say, but Mr. John, the side that is 5 units looks a lot shorter than the side that's 6 units. That's because my shape is not drawn to scale. So do not go by how it looks. Instead, use the numbers, the information that they give you in the puzzle. Now, in some of the puzzles, the shapes will look like this. And they will tell you that this length is 6. And they will tell you that this piece of this side is 2. And you will have to think about what this part of the side is. Well, what you do here is that you know that this whole side is a length of 6. So part of it is 2, the other part must be 6 minus 2 or 4, because 2 plus 4 is 6. Okay, so remember that as well. You will see that in these puzzles. Okay. One more check-in before we dive into a puzzle. These are area mazes. What does this idea of area mean? Well, in math, area is the measurement of the space inside of a 2-dimensional shape. Here's an example. I'm going to draw a rectangle. Again, it's not drawn to scale. And I'm going to tell you that this side is 2 units and this length is 4 units. When I first learned about area, I knew that I could make a grid inside the shape and count the boxes to find the units inside the shape. So I have 2 units horizontally and I have 4 units vertically. So if I wanted to know the area, I could count the number of units and I could label them like I'm doing here. So the area of this shape is 8 units, and we write 2 to stand for square units, or we write 8 square units. That's the space inside of the shape. As I continued learning math, I also learned that we could use multiplication to find the area of a shape. So let me show you this example. The length of this side is 3. The length of this side is 4 units. I'm trying to find the area, which is the amount of space inside. I know the area formula is length times width. So in this case, area is 3 times 4. Area is 12 square units for this shape, because 3 times 4 or 4 times 3 equals 12. Okay, I think we're ready to do our first area maze puzzle together. So here's the puzzle. I'm going to draw it on my piece of paper, and I want you to sketch or draw it as well. So sketch in all the information that they have given us, and then we will start to talk about how to solve it. Remember, it does not have to be drawn to scale, so your drawing doesn't have to be perfect, it just has to have the information that they've given us. Okay, so here's my messy drawing of how we start the puzzle. Okay, so you follow along and do it with me. I know that opposite sides of a rectangle are the same length. So if this side is 6 in length, I know the opposite side is also 6 units in length. And I also know the area of this shape, and this one down here is 30 inches square. The one on the top is 42 inches square. So we're dealing with inches. So let's look at the one on the bottom here. It's telling me that this length is 6 and the area is 30 inches square. So I have to figure out what this length is. And it's some number times 6. Some number times 6, which will equal 30. Or I can think of it 30 divided by 6 equals this number. Okay. So I know my multiplication facts. I know how to work with division. So I know that this length is going to be 5. Because 5 times 6 is 30. And 30 divided by 6 equals 5. So that means that the opposite side is also 5. And this line is also 5. Okay. 5 times 6 equals 30. Okay. Let's look at the top rectangle. Again, the opposite length is also 6. And I know that the total area is 42. So how could I figure out what the length of this side and this side are? Well, do the same thing. Some number times 6 equals 42, because that's the formula for finding area, length times width. Okay, I could also do 42 divided by 6 equals the number. So I just figured out that this other side has to be 7 inches, and also this one has to be 7 inches, and the one on the bottom has to be 7 inches. Okay. So now I think I can figure out the area of this shape that had the question mark, because I know one length is 5, and the opposite length is 5, and the other dimension is 7. So if I think of 7 as the length and 5 as the width, I can do 7 times 5, which will equal 35. So the area is 35 square inches, or 35 inches square. So I can write that in here. And I've solved the puzzle. Okay, I think you're ready to try one on your own. So here is the puzzle. Again, that you're going to have to copy onto a piece of paper. And I will do it on my board as well while you are copying it for yourself. And it will show you what I was doing after I give you a chance to figure it out for yourself. So remember, the formula for area is length times width. And in these shapes, which are rectangles, opposite sides are always the same length. And if I know the area of the shape, but I don't know the dimensions of one of the sides, I can use division or multiplication to figure out. Okay, here's the puzzle. And now I can start thinking, so you can think along with me. And my first thing I know is that this length is 6, so that means the opposite length is also 6, and also the one in the middle. And I know that if this length is 6, this length up here has to be 42 divided by 6, or the number multiplied by 6, which gives a product of 42. So I know that this length is 7, because 7 times 6 is 42. Okay, now I'm using my logic, and this is a rectangle, so I know that if that length is 7, then this length also is 7. And if the area of this part is 35 inches squared, and one of the side lengths is 7, then this length has to be 5, because 7 times 5 is 35, or 35 divided by 7 is 5. If this side is 5, I also know that its opposite is 5. And then using the same logic I've been using, this area here is 20 inches squared. Well, if this length is 5 inches, what's this length down here? Well, it has to be some number times 5, which gives a product of 20. So that has to be 4, because 4 times 5, or 5 times 4, is 20. And I know that 20 divided by 5 equals 4. If this length is 4 here, that also means that this one up here is 4. So now I think you can figure out the area of the shape where it has a question mark. We know that the formula is length times width. The area here is 24 inches squared, or you can write 24 square inches. We got it. There's one last puzzle I'm going to leave you with. For this puzzle, you notice that they have labeled part of the length of the side here and part of the length of the side here. So we have to figure out the entire length of the side. Be careful. I hope you enjoy doing these puzzles. And here is how you can find a whole book of puzzles to work through. If you type into your search engine, it will give you this whole book of puzzles. And the best part of it is that it will also give you the solutions. So good luck, enjoy doing area puzzles, and remember, if you can do math, you can do anything.
Have you been feeling down? Do you need something to pick you up? Well, I encourage you to do something that makes you feel happy and teaches you about life.
Hey everybody, welcome to Adventures with Mr. M. I'm Mr. M and I'm glad you're here. Today I'm wondering, do you or someone you know have a cell phone? Chances are you or someone you know likely do. Did you know that cell phones have a lot to do with the field of science called chemistry? How, you may ask? Today we're going to be investigating some of those connections. Today, we're going to be reading an article from one of my favorite magazines called Chem Matters. This article is called Be Smart, Recycle That Old Cell Phone, and it's by Brian Rohrig. Toxic heavy metals. The lifespan of a typical smartphone is 21 months. Even though smartphones are made to be quite sturdy, their constant use and the occasional drop takes its toll, so this short time period should not come as a surprise. And with newer and fancy models being churned out every year, U.S. residents throw away more than 140 million cell phones every year. If you cannot sell your old cell phone, what should you do with it? One option is to toss it in the trash. Doesn't it get shipped to a landfill where it is buried in some remote location far from human habitation? The United States generates more than 2 million tons of electronic waste each year. Even though electronics make up only 2% of the waste in landfills, they represent 70% of the heavy metals found in landfills. It is these heavy metals that can cause long-term pollution risks and seriously affect human health. Dozens of different kinds of metals are found in a typical smartphone, many of which are toxic. Lead, nickel, arsenic, and cadmium are just a few of the toxic metals found in most smartphones. In China, for example, soil levels of toxic metals at electronic disposal sites have been measured to be between 10 and 100 times greater than normal levels of toxic metals in soil. Exposure to these chemicals can result in a variety of adverse health effects, including birth defects, neurological or brain disorders, and kidney damage. Recycling cell phones. You can also recycle your old cell phone. Most stores that sell cell phones offer free recycling of old phones, and many companies give you cash for dropping off unwanted cell phones for recycling, even if they do not work. Here's an example of an Eco ATM. It's a recycling kiosk in the state of Washington that offers instant cash for cell phones and other small devices. You might see this in a store near you. These cell phones are sent to a recycling center. If the cell phone is in relatively good shape, it may be refurbished and donated to organizations that serve those in need, such as military charities, senior citizen centers, and domestic violence shelters. Other cell phones are disassembled and their components are reused by the cell phone industry. Because many of the metals in cell phones are becoming increasingly difficult to find in nature, recycling these metals makes sense both from an environmental and economic standpoint. Despite the obvious benefits of recycling, most old cell phones still end up in the trash. According to the U.S. Environmental Protection Agency, of the 141 million cell phones discarded in 2009, only 12 million were recycled. A great service project would be to set up a cell phone recycling program in your high school. It only takes one person to make a difference. Let's go ahead and talk about the elements that you can find in a smartphone. Let's talk about the screen first. Indium tin oxide. Indium is an element on the periodic table, which consists of indium oxide in which of some of the indium has been replaced by another metal called tin. It is used in a transparent film in the screen that conducts electricity. This allows the screen to function as a touchscreen. The glass used on the majority of smartphones is an aluminosilicate glass, which is composed of silicon, aluminum, and oxygen, 3 elements that are found in abundance here on planet Earth. This glass also contains potassium ions, which helps to strengthen it. Also, a variety of rare earth element compounds are used in small quantities to produce the colors in the smartphone screen. Some compounds are also used to reduce UV light penetration into the phone. Let's talk about the battery that's found in a smartphone. The majority of phones use lithium-ion batteries, which are composed of lithium cobalt oxide as a positive electrode and graphite carbon as the negative electrode. Lithium, cobalt, and carbon are all elements found here on planet Earth, and we can look up information about them on the periodic table of the elements. Some batteries use other metals, such as manganese, another element, in place of cobalt. The battery's casing is made of aluminum, which is another common element. Now let's talk about what kinds of elements you can find on the inside of the cell phone in the electronics. Copper, a metal element, is used for wiring in the phone, while copper, gold, and silver are the major metals from which microelectrical components are fashioned. Tantalum, another element, is the major component of microcapacitors. Nickel is used in the microphone as well as for other electrical connections. Alloys, which are mixtures of metal, including the elements praseodymium, gadolinium, and neodymium, are used in the magnets in the speakers and microphone. Neodymium, terbium, and dysprosium, other elements, are used in the vibration unit. Pure silicon is used to manufacture the chip inside of the phone. It is oxidized to produce non-conducting regions, then other elements are added in order to allow the chip to conduct electricity. Tin and lead are used to solder electronics in the phone. Newer lead-free solders use a mix of tin, copper, and silver. Finally, let's talk about what holds the phone together, the outside case. Magnesium compounds are alloyed to make some phone cases, while many are made of plastics. Plastics will also include flame retardant or flame resistant compounds, some of which contain bromine, while nickel can be included to reduce electromagnetic interference. Wow, that was a lot of talk about chemistry in cell phones. Did you notice how many elements there are in one cell phone? Let's go ahead and just make sure we know where to find all of these elements if ever we want to look up more information about them. To find out more information about these elements, we need to consult a table called the periodic table of the elements. The periodic table of the elements can be found online or in a chemistry textbook and in other most science textbooks. And if you'll take the chemistry regents eventually, you're going to get a copy of this in the form of the chemistry reference tables. On the periodic table, we can find many different pieces of information about the elements. Here's an element that we all know and love and need in order to survive: oxygen. Every element on the periodic table shows the following information. At the top, we have the atomic mass. The atomic mass is the amount of one atom of that element's weight. Then we have the element symbol. The element symbol is like an abbreviation of the element. In this case, oxygen's atomic symbol is O. Then we have the atomic number. The atomic number will tell you the number of protons and the number of electrons in an atom of that element. Over here we have the selected oxidation states. This tells you what kind of ion the atom will most likely form when it loses or gains electrons. In this case, it's -2, so we know when oxygen bonds to other substances, it most likely will want to gain 2 electrons, having an overall charge on that atom as -2, making it an ion. Finally, down here we have the electron configuration. This tells us the number of electrons in each shell of the atom. In this case, in the first shell of oxygen, there are 2 electrons, and in the second shell, there are 6. Total of 8 electrons in an atom of oxygen. Why are we looking at this? Because all of the elements that we just talked about in the chemistry of cell phones can be found right here on the periodic table of the elements. Check it out and see how many you could find. I hope you enjoyed this episode of The Adventures of Mr. M. Hope to see you again soon.
Thank you for joining us today. Have a great day today and tomorrow.